Okay, Algebra 2, we're dealing with 5.15, a very surprising lesson. We're going to simplify complex numbers. Complex numbers are really going to involve imaginary numbers. Now that can sound very, very strange. Let's read this together. Mathematicians created a new set of numbers to solve x squared equals negative 1. Guys, if you were to solve x squared equals negative 1, kids would say, well, from the last couple of days, we'd take a square root, and there'd be 2 square roots. But what have we been saying when we'd see the square root of something negative, like the square root of negative 1? No real numbers. And that is true. There is no real number for which that times itself, it would be negative 1. What we're going to see, though, is what if there is a solution? We would call this the square root of negative 1. The square root of negative 1 we're going to define to be an imaginary number. Now, immediately, that can sound crazy. You can say, why in the world are we dealing with imaginary numbers? It makes it sound like this is made up stuff and it has no real value in the real world. And surprisingly, these imaginary numbers do an amazing job modeling electricity. If you know an electrical engineer or an electrician, you ask them if they've studied imaginary numbers. Undoubtedly, they would say, oh, you bet. Because they can really represent the way electricity behaves. Kind of surprising. So it's not like what we're studying today is of no earthly good. It does have real value. But what we're seeing is whenever we've got the square root of negative 1, here's our big definition. Square root of negative 1, we just call it I. So some review. Hey, this symbol looks really, really scary. It's actually a symbol from the Greek alphabet. Anybody know the name of that Greek letter? That's omega. Yeah, it's omega. So you've got the square root of omega times the square root of omega. And you'd say, well, wow, what do you think that would equal? It's just omega, right? What about the square root of 2 times the square root of 2? That's just a 2. Right? That's just a 2. Whenever you have 2 of the same thing inside of a square root, we take it out. What if I had the square root of negative 1 times the square root of negative 1? What do you think? 1. Negative 1. Right? It's just negative 1 itself. What we're seeing is, here's another definition, and we're seeing why it's true. I squared, we're going to need this later. Wow, I squared is always going to equal negative 1. Okay, I squared. I itself is the square root of negative 1, but I squared is negative 1. Now, the rest of the problems here, as we look at these next 4, we're just going to do some breaking down. Square root of negative 5, we've got a student who thinks he knows what to do. What should we do you think? Yeah, good. Guys, please hear this loud and clear. If you know this, these problems are actually going to become routine. They're not going to, it looks really complicated. It's really not. You see a negative inside of a square root. Take out an I. If you see a negative inside of a square root, plain and simple, take out an I, and then see if you can break down your radical. Now, can I reduce the square root of 5? No, 5's prime. We're done. That's all you do. You go to B. You'd say, well, I've got a negative inside. Guess what you do? You take out an I. And then you ask yourself, well, can I break down the square root of 16? Yeah, the square root of 16 is 4. You don't even need to do a division tree. You could just say, well, this is I times 4. You know how we're really going to write it is 4i. You're done, right? Now is where it's going to get to be a little bit more complicated. You do take out your I, but let's be honest, this is where you have to do some review. The square root of 8 can be simplified. So make yourself a little division tree. and ask yourself which primes we can divide out. A 2 for sure. 8 divided by 2 is a 4. Try a 2 again. 4 divided by 2 is 2. Look at that. I've got 3 2s all multiplied in a row. Now, the big question is then, can I find any doubles? I can. I've got a pair of 2s, 2 2s. So that means pull one of your circled items out, ignore the other one. Whatever you didn't circle, you leave it there. Your final answer, guys, is 2i radical 2. Yes? Here, hold on. Last one of the day. You could have a negative out in front. Sometimes kids are a little worried about that. They'll say, how do I deal with that? Answer, you just pull the I out. As always, it's just that now you've got a negative out in front with the I. But what's the square root of 4? Square root of 4 we know is 2. Final answer is negative 2i, and we are done.